Hi everyone, and welcome to today's webinar, which is an introduction to LimitState Fix. I'm Tom Pritchard. I'm Principal Engineer here at LimitState, and I'm going to be your host for today. Today we'll be giving you an introduction to our one-stop shop mesh repair software, which is LimitState Fix. And if you have any questions that may arise during the webinar, then please do feel free to enter them in the Q&A functionality, which should be in the webinar interface in front of you. I will try and get around to all the questions at the end. Sometimes we don't have enough time to cover all of them. If we get to that stage, then we will follow up by email, so don't worry. We'll do that later. So just what we're going to look through today. Firstly, I'll tell you a little bit about LimitState Fix and then go into the features of LimitState Fix version 4, which is the recently released version. Then we'll take a look at some examples of problems being fixed using the software, and then I'll summarize at the end, and obviously then we'll have the Q&A. So firstly, a little bit about LimitState Fix. So what's the need for mesh repair? Watertight and error-free meshes are required for processes further down the line. So mainly we tend to be thinking about things like 3D printing, but you may also need them for such applications as computer graphics or a range of other end users. And a lot of the time, errors will creep into a mesh file either as a result of how the original model was generated. For example, if you're undertaking Boolean operations and they aren't performed properly, or as a result of the meshing process itself. For example, if you're meshing quite a complex point cloud from a scan, or if you're interpreting a particularly complicated solid geometry. And fixing these errors can be a laborious process. There are free applications that purport to help you, often though the repair functionality in those is only a small and quite limited part of what the application was designed for in the first place. And that means that getting the right results from healing can be quite time consuming and at the very worst an impossible task. There's also a range of paid for applications out there, but again, the repair functionality is often a smaller part of the overall offering, and the results are not always the best, and you're paying a premium for it. So what's required in this sort of situation is a one-stop shop, an application where the speed and the quality of the repair is put front and center. So that's where LimitState Fix comes in. It provides users with a single application to take an error-filled mesh and repair it quickly at the touch of a button. How does it do this? Well, we've taken what's arguably the best industrial strength mesh repair technology available, which is Polygonica, and incorporated functions from that into a user-friendly tool that's primary purpose is to help you repair meshes quickly. And when we've tested the results from LimitState Fix against alternative repair methods and technologies, it's proven time and again to be faster than those and to give the highest quality results out of any of the tools available. So this is perfect if you're considering how to incorporate mesh repair into your 3D print design and manufacturing workflow. And with that in mind, Fix version 4 incorporates a number of features that help make preparation for print even simpler. And we're going to take a look at some of those today. But first, I think the best thing to do is say a few words about Polygonica, the underlying technology that's within LimitState Fix. So Polygonica is a set of industry-leading mesh processing APIs that have been developed and distributed by MachineWorks since 2011. And actually, I think the libraries themselves for these APIs go back quite a lot further than this. So there's a lot of R&D that's gone on behind them. And what MachineWorks pride themselves on is providing very well thought out and unique technologies for fast and, most importantly, robust mesh operations. Polygonica itself is used behind the scenes by a number of very, very well-known 3D printing companies, including machine manufacturers, print bureau, and software providers. And it's also used in a number of high-value sectors, including medical and dental fields, as well as aerospace industries and similar. And LimitState Fix, as software, provides access to the core mesh healing functionality of Polygonica in an affordable and easy to use package. So a quick look at the features of Fix version 4. And the bread and butter of LimitState Fix is the auto fix functionality. And this single button, which we'll see shortly, will take your error-filled mesh and perform all of the operations that are listed here and leave you with a watertight and printable file. So it will close the solid, it will orient any normals that are out of step with the surroundings, it will remove self-intersections and noise shells, which are small shells that aren't part of the main geometry that sometimes creep in, and it will also repair any non-manifold edges and finally validate the layout for you. And more often than not, this is all that you have to do. Just click the button, wait a short while, and save the fixed results at the end of it. However, if it's necessary, you can also run each of these operations in isolation. So each of these functions is available as a separate feature within the software. And in response to user feedback, and with the aim of making your workflow even smoother, we've also added a number of features to Fix 4 which relate to 3D printing and print platforms. So now you can load in a number of objects into a print platform, as well as healing them. You can arrange, snap, and scale, as well as validate the layout and export the results both as a mesh, but as a slice file as well with a specified layer thickness. So that's enough about the background to the software. I think the best thing to do is to jump in and look at the software itself. So the first thing we're going to do, actually, we'll go back to the presentation, is look at what's probably one of the best known 3D objects out there, which is the Stanford Bunny. And we have a problem here where we have the model with a large number of errors within it. So if we go back to the software, have a quick look at the interface first. So we have a ribbon bar at the top, which has all of the operations that you might want to take listed along it. On the left-hand side here, we have a project tree. On the right-hand side, we have errors and properties listed. And then we have a main viewer window and an output at the bottom. And as well as those, we'll see in a second, we also have a message bar and a progress bar at the bottom of the screen. But the best thing to do is to open a new project. So if we click on new, we can see here the first thing that comes up is a workspace setup, and by default what will happen is that we will have a volume that will respond to the size of the objects that are placed within it. So it's not a machine in itself, it's just a cuboid that will encompass all of the objects that you load into the program. You can select from a range of built-in models from a large number of manufacturers, but for the time being, what we're going to do is just keep this default. So if I click OK, we can see now we have this volume, the floor is the grid here, and we want to import our file into it. So I just go up to the top left here, click Bunny Holes 2 and open, and what happens is LimitState Fix will load in the file, and it will take a few seconds. On the left hand side, in a second you will see that the project tree has arrived, and on the right hand side we can see all of the errors that exist within this model. So we can see actually we've got the worst ones is self-intersections. We have over 11,000 of those, also open edges and non-manifold edges, taking the total number of errors in this particular file to over 20,000. And what we can do is we can rotate this just to get a better look at what the problem is. So we can see here, we have a nice big hole. We have some more holes in the base of it. And then these yellow areas here are actually non-manifold edges, which if we zoom in a little bit further, we can see are actually around the edges of self-intersections. So there's quite a lot of different errors within the problem that we want to be fixing. So the first thing we want to do is look at auto fixing it using the default settings. So I'll just go up to the ribbon bar, and right in the middle is this auto fix button. I click it and it will take a couple of seconds, and you can see already how quickly the software works at fixing and healing your problems. And on the right hand side here, just validation that there are no errors in the problem anymore. On the left hand side here in the project tree, you probably didn't notice it at the time, but the icon that relates to this particular object has gone from being pink to blue to show that it's been fixed. And if we look around, we can see that there aren't actually any errors highlighted in any color other than there being the base color for the object. But one of the things, if I look here at where this hole in particular was filled, the results of that aren't necessarily what we would like. So what I can do is, if I just undo that last step, so introduce those errors again, one of the things you can see at the top here is the configuration. If I click on that, we get a settings dialog, and we can change the hole closing algorithm. So by default, we're using a fan because it's quite quick and will cover large areas relatively efficiently, but we have a number of different options that we can choose from, and the best one I think for this would be the features smooth option for closing. So if I select that, what that's then going to do is look at the size of the mesh that's around the hole, the way in which it's moving, and try to take information from that in order to then close that hole up. So if we auto fix now with this feature smooth hole closing algorithm, we can see it takes about the same amount of time, but the results that we're getting are much superior. So now we're happy with this, let's save it for print. So you can see all the fix options up here and the auto fix button are grayed out, as well as in the error tree, there are no errors being listed. So we know that we can export this for 3D print without worrying about the fidelity of the model itself. So what I could do is export straight away, but just as an aside, what I'll show you can also do is simplify operation. So if I click on this button, we can see that actually we have almost 70,000 triangles within the problem as it stands, and maybe we want to make that a lot simpler in order to manufacture it. So we can set a target number. So if I put 10,000, so reduce it by a factor of 7, and we can also limit the error on the triangles that are created from this simplification. So at the moment, we've got a maximum error of 0.1. If I click apply, it'll take, again, a couple of seconds to run through. And we can see now there's virtually no change to the model itself. If I just click on there again, we can see actually we've reduced it down. We didn't quite get down to the 10,000, but we have reduced the number of triangles by about half. So that's good. So now I want to go to export. So just click on this option here, and we have the choice of exporting either as an STL or AMF, so mesh file, or as an SLC or a CLI, so as a slice file. So I can choose STL. I'll call it bunny fixed. Click on save, and then we have the save option. So I'm going to save it in a binary format, and I'm going to take off the rounding precision. So behind the scenes, LimitState Fix is saving everything to a high decimal precision. What you can do when you're exporting is round off all of those coordinates in order that you can then increase the chances of it being read in without any flags in other software. But within this, I'm going to turn off that rounding down precision, and we can see at the moment it's saying mesh is watertight. Click OK, and If I just remove that and import my fix file, we can see here no errors in the problem at all. So we have a nicely fixed single Stanford bunny. We return now just back to the presentation. So the main thing from that was showing you how easy the software is to use, how quick it is to do the repairs, and how robustly you can get those repairs. The thing to point out, I guess, is the hole closing algorithm that we changed. So we can see here on the left, that was the fan closing, which worked but may not be 100% acceptable in terms of your model, but you can just choose a different closing algorithm and you get a different result. So this fan one on the left, if you have large flat spaces that you want to cover, then that should be perfectly fine for those. For a smooth with features, then you may want to use that on problems where you have more undulating surfaces and a slightly more sort of textured surface. So for this next example, what we're going to do is look a little more at the multi-object interface and the built-in platforms within LimitState Fix. So we're going to start a new problem. And in this one, I don't want to start with the default. What I'm going to start with is my own platform. So we can see we have all of these different ones that are built in already. But at the top, there is an option to add a new one. So I'm going to call it my platform, and the volume I'm going to have is 300 millimeters cubed. A layer thickness of 2 millimeters, so a slice of 2 millimeters, which isn't particularly realistic in the great scheme of things, but it will allow us to look at the output much easier. So if you go back through the other platforms, you'll see that those layer thicknesses are generally much lower than this. And a packing margin of 0.1 millimeters. So that comes into effect when you're arranging objects within the volume. So if I click OK on that, you can see now that my platform is selected with all of the information that we've just added. Click OK. And what I want to do is import from here my 3 different STLs that I want to be fixing. You can see that they are from the dental and medical world. So we have an implant here, we have the model of a jaw there, and we also have a model of some teeth which is hidden behind them. And when we're importing more than one model at one time, what we get is an arrange dialog. So what I want to do is say, okay, I want a best fit, and I want to focus on the bottom left of my platform. It's saying it couldn't perform clash detection, and that's because some of the models are slightly outside of the volume, but we're not too worried about that. So I click OK, and you can see now that it's arranged my models according to that tolerance that we put in earlier and pushed everything to the bottom left corner of my platform. If we look on the left-hand side here, we can see in the project tree that each of the different objects is listed individually. And when I have one selected, it will have a solid line around it in the viewer window, and on the right hand side the errors associated with that particular STL file will be shown up. So I can click the dental implant and we can see that only has 8 errors. The lower jaw, which is this one in the middle, has several thousand, and the large teeth similarly a few thousand errors in it. One of the useful things actually is if we zoom in a little on this implant here, it's difficult to tell where the errors might be in it, and that's the sort of thing that might happen from your own experience. So what we can do is expand this tree here and click on there, and we'll get a little yellow arrow that tells us where that error is. So we can zoom in, and yes, we can just see the green line there, which is showing an open edge. So the green in this icon here corresponds with the green here. So it's an open solid or an open edge there. So if I zoom back out, what we can do is if we selected a particular model in this left-hand side here and clicked auto fix, that would heal only that model. But if we wanted to do it a lot quicker and fix everything, which again is generally the case, just select the top of the project tree and click auto fix, and it will fix all the errors in all of the files. And it's going to take a little while to do that. We can see at the bottom here saying at the moment that it's closing a solid. At the right hand side we can see the progress bar, and once it's gone through all of the different steps, so closing, removing the self intersections that we can see here, making it manifold, then it will return the 3 different fix files to us. So hopefully we can see that progress bar is getting towards the end there. So we're close to the end of the fixing process. We're also getting output into our output window telling us which stage that we are on. So it's saying, okay, I've closed the solid using a fan closing algorithm. I've fixed the self intersections. I've removed any insignificant shells, and the actual healing itself took just about 12 seconds. And now we have 3 models with no errors in them. So again, they've turned blue in the project tree. When we select them, they're showing no errors on the right hand side. And in the tree, what we can do, we can select them and export, or if we select the top level, we can export everything together. If you select export individually, then it will export each object as a separate file. And if you select convert to parts, it will take any separate shells in the whole project and save them as different files. So at the moment, each one only has 1 shell, as we can see in the properties down here. So we would get 3 individual files. But actually, I think what we want to do is if I export as a whole, and this time what I want to do is instead of exporting as a mesh file, I'm going to export as a slice file. You can see I've already done it earlier today, but I'm going to save over that one. So we'll save it as dental parts.slc. Do I want to replace it? Yes. And then what you need is an application that will open slice files. In this case, I'm using Rhino, but you can use whichever you wish. And we can see here the export of those 3 files. And again, we were using the 2mm layer thickness in order to show the slices clearly on screen. If you were doing it in real life, obviously you'd be using a lot lower value for that layer thickness. So that's gone through a little about multi-object fixing. We just return briefly to the presentation. We've seen that we can define our own working platform and that we can import many objects at once, fix them together, and then export them either individually or as one entire file in itself. The last of the examples we're going to show today is just about converting a single file into parts. So we return to fix, we'll start a new project, and in this case I'm going to choose an Arkham platform so we can see all the dimensions and everything in there. Layer thickness much lower than 2mm. And then what I want to do is import my file. So if we go to example 3, you can see this is going to be one that involves mechanical parts. What we've got is a scale warning on import. So it's saying, okay, the object that you're bringing into this platform seems to be quite big. Are you sure that that's the scale that you want to be using? And if you've got a mistake for some reason, maybe if you've saved something in meters rather than millimeters or vice versa, then you can change that here. But for us, it's okay. And we can see here in the project tree, that's just one STL file with 3 separate components. So we have an end of arm tool, we have what's actually part of a satellite mount, and a random mechanical part in the back right there, with a number of errors. So we've got 400 or 500 errors in the project. We can see again flip normals, we can see solids that are open, and then there's non-manifold edges as well. So if I click auto fix, it will take a few seconds like it did previously, because we have 3 different shells to be looking at, and go through the process of closing the solids, fixing the self intersections, making it manifold, removing any noise shells. And once it's done that, we can see again no errors on the right hand side, and our little icon there has turned blue. So if I click this validate button here, saying cannot perform clash detection because there's only one model, but it turns green to show that it actually all lies within our platform. And the same, we're going to look at converting it to parts. So if I right click here in the project and click the convert to parts option, what you'll see happen in the screen is it will take that one object away, and then it will replace them with 3 individual parts. And we can see that they're all fixed, and they've also been oriented to the back left of our platform there. So now we've done that, what we can do is we can say, okay, export individually, and we've got LimitState fix 8, which is as good as anything for our base name. If I click save, we'll keep the rounding on in this case. We can see that the meshes are watertight. If I click OK, and then bring in my thing here, you can see we have LimitState fix 8, 1, 2, and 3. And what I'll do just before the end is if I start a new project, I can, from the screen that you can't see, import those 3 different STLs. Again, it's complaining about the scale, thinking that it's probably a little bit too big. But there we have our 3 models separately, so we can move them about, do what we want with them. Okay, so hopefully that's given you a brief but good introduction to LimitState Fix and what's possible with it. We've seen that it repairs 3D mesh files quickly and robustly, and that there's no need to undertake any laborious manual fixing. The auto fix functionality will perform a best first guess repair for you quickly and robustly. There's a range of features that are designed to integrate into your 3D design and print workflow, and multi-object repair and export functionality has been incorporated into Fix version 4, and you can output as a fixed mesh or in slice file format. So we've got just 1 or 2 minutes left for Q&A. If you have any questions, then do feel free to put them into the chat now. Okay, so I've had a question, how do I get hold of a trial? That's actually a very good question. So if you visit LimitState.com/fix, you can download a copy of the software and try it for yourself. It won't let you save or export, but all the other functionality is there for you to try out and see that you can fix the files that you are getting in your work. You will require a license, obviously, if you do want to save or export, and they're available from that same site, LimitState.com/fix. And there's one more question, which is related to the webinar itself. It's saying, will there be a recording of the webinar available? And the answer to that is yes. What we try and do is make sure that we have a recording that's put up on our YouTube channel, which is LimitState Software. And that's normally within a day or so of the end of this webinar. So it should be there by the end of this week. And for anybody that is registered for the webinar but didn't manage to make it, you should receive an automatic email with the link to the recording after the end of this. So that's brought us to 1 o'clock. I'd just like to say thank you to everybody for joining us today. Hopefully you've found this webinar useful and informative, and I look forward to speaking to you again soon. Thank you.